Last example, of course, throws you a little bit of a curveball because instead of just dealing with these regular slope y-intercept lines, we're throwing in one of our special lines. Remember, the horizontal and vertical lines, special lines, this is a horizontal line through y equals 4. So that's the easiest one to graph right off the get-go. I'm just going to throw down a line y equals 4. I didn't want it to be that color, so I will change it to a green because I made it green on the thing. Let's go there and let's go there. Okay. And we're going to throw some arrows on there to show that it continues on forever. And this happens at y equals 4. And then our second equation, what do we know? We know the slope is 5 over 1. Because there's no fraction, we can always force a fraction. That's up 5, right 1. Okay, and our y-intercept happens at -1. So -1, up 5. 1, 2, 3, 4, 5, right 1. Woo! There it is. And I'm not even going to draw anymore because those are far enough away for me to get a good idea of what this line's going to look like. There. Extend it the other way to there-ish, and then throw on some ends. Boom, 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 boom. Y equals 5x minus 1. Point of intersection happens right there, POI, at +1, +4. Therefore, POI at 1, 4. We're going to move into the algebraic stuff in the same breath here because I want you to see that there's an important connection you need to make between when the point of intersection and what it actually means for the lines. So if we look at these two lines, they've already been drawn for us. Just by looking at this graph, we can find the point of intersection right there at 2, -3. So for this graph, our point of intersection is at 2, -3. Let's create a table of values just to get an idea of what's going on. So -1, we plug in a -1 there. 2 times -1 is -2 minus 7 is -9. 2 times 0 is 0 minus 7 is -7. 2 times 1 is 2 minus 7 is -3. Do you see the pattern developing? We're going up by 4s. So we should go 2 times 2 is 4 minus 7 is what? Oh, I screwed up. I screwed this one up. I'm not stopping the video. I'm just going through with it. Usually I would stop the video and start over. I'm not doing it. 2 times 1 is 2 minus 7 is -5. Then we would go -3. Then we would go -1. So we're going up by 2 each time, which makes sense because our slope is 2. So over here, -3 times -1 is +3 times +3 is 6. -3 times 0 is 0, +3 is 3. And these ones, you should be going down each time by 3. And then it would go to -6. So down here, it wants you to look at these two tables of values and ask, like, what do you notice about them if you were to compare? And for both of the tables, at 2, when the x is 2, y is -3. That is the only coordinate that is common. And that's because it's the point of intersection. So at x equals 2, y equals -3, they have the same x and y values. That's what the point of intersection means, that you've got the same x and y values. This is really important when we're doing our algebraic stuff, and I'll talk about that in the next short video.